Hi children, today our topic is to learn about radioactivity and particles. Before we learn about radioactivity and particles, we should know about the structure of atoms. We know that atoms are made up of electrons, protons and neutrons. In our next slide, we will learn about the structure. So basically we know that protons and neutrons are isolated in a small volume called nucleus. In Rutherford's Goldfield experiment, we have already learned in our previous topics, we already knew that protons and neutrons are isolated into small volume called nucleus. And electrons are moving in fixed orbits around the nucleus. In the structure of the nucleus, the protons are positively charged and neutrons are zero charge. That means basically neutrons are neutral substances, no positive or negative. And electrons are negatively charged and as I mentioned before, they orbit around the nucleus. This is the small structure of the nucleus. This is not the exact shape, but to understand, we can categorize or we can demonstrate a nucleus somewhere like this. Atom, sorry, nucleus atom. We know that this is the nucleus. You can understand that is positively charged protons. In this 3D diagram here, red color ones. They were stagnate into a small volume with what? With neutrons. Neutrons are negatively charged substances. And these electrons are orbit in a paths called orbit. The definition of orbit is the most possible points where an electron can stay in around a atom. That's the simplest definition of a nucleus. So nucleus, around the nucleus, you can see that the electrons are moving in fixed paths called orbits. Right. So here like that, the electrons can move in orbits, just as explained before. And neutrons and protons are stagnate in the center of the atom. You can understand, you can observe from this diagram compared to the other area where the new electrons are moving. This nucleus is pretty small. The nucleus is stagnating to a very small volume. Then, according to our previous concepts, we know that protons are positively charged. Then, if you keep two protons somewhere like this, they tends to repel each other since they are positive charges. So this is the F2. F2 is a force that is called the repulsive force. Because of this repulsion, the protons must be separated into each other. Then there is another factor of force, that is the force F1. I am going to explain. We will learn much detail about this fact in our A levels. That means if you keep two masses, there would be an attraction between them. This is called the universal gravitational law. We learn much details in our A2 level physics. But for the moment, you have to understand, if you keep two masses, there would be attraction between you all. For example, if you are sitting next to your friend, there would be attraction to your friend. And you are sitting in a chair, you have attraction to the chair. And you are sitting in a classroom, you are attracted to the classroom wall. But why we do not just like go and paste into the wall or paste into your friend or place into the chair? The reason is that there are several substances and materials and different kind of objects are around you. So you are attracted to all of these objects around you. As a result, you are working in a some kind of a balanced system. But compared to the gravitational force, where you attracted towards our earth, other forces are negligible. That is why you do not go and attract to the other objects around us, right? Then if you keep the two protons somewhere like this, due to the repulsion, the force F2, they tends to separate it. Due to this attraction force of the mass, they tends to attract. Then, but when you consider about the general concepts, this F2 is pretty larger than F1. Compared to F1, F2 is very large because we know that negative or sorry, some kind of light charges are highly repulsive. But according to this concept, if this happens, the protons cannot exist somewhere like this. It cannot stagnate into a small volume like this. They should be scattered into pieces. The nucleus should be scattered into pieces. But how does this attraction occurs? The simple mechanism is the attraction of the actually this should be neutron. By mistake, I just made it as a proton. This should be neutron, not a proton. So just shall we make it right now? I will make it a neutron. Yeah, now it's correct. Yeah. Neutrons, right. Then you know that neutrons are neutral. Therefore, they do not attract or repel into any kind of any other substance of the proton or anything. But you know that neutron also having a very higher mass, which is that mass is similar to the mass of a proton, almost similar, not exactly. Therefore, there should be attraction between them. There should be attraction between this neutron attract towards this and this one also attract towards this. The final result is you can see here like these neutrons are capable enough to attract these protons into each other and make the nucleus stable as we observed in our previous slide. It's a simple mechanism of the nucleus, right? Okay, let's go to the next slide. The next theory where we need to understand is the atomic number and the mass number. If you happen to learn chemistry, sometimes you may already know these facts, but you have to understand what do you mean by this atomic number. As I mentioned before, the nucleus is made up of protons and neutrons. The atomic number is the number of protons in a nucleus. So in this case, that is a one fact where we can define some kind of a element. If the proton number is similar, we can say that is the same element. If you get two substances and if you count the number of proton in a one atom of the first substance, and if it is equals to the number of protons in the element in the second substance, we can say the elements are same. Elements are same. Therefore, if you come across two substances with same atomic number, we have to understand that that is the same element, right? Then what is mass number? As I mentioned before, nucleus is made up of neutrons and protons. If you get the number of protons and number of neutrons all together, that number is called the mass number. Usually in a element, I think you have already seen this in your periodic tables. At the bottom you represent the atomic number and at the top you represent the mass number. So if you happen to see this one, there are two protons. Altogether, protons and neutrons, there are four of them. That means there should be two neutrons and altogether there should be four substances in the nucleus. That is the basic concept of learning about atomic number and the mass number. Right. This is a very important topic when you are learning about this radioactivity, isotopes. What do you mean by isotopes? In our previous slide, I already mentioned that if atoms are there with same atomic number, if there are two substances with same atomic number, the element should be same. In general, we know that number of protons and number of neutrons in a nucleus is equal. Yeah, equal, not a problem. There are some situations we can see there are more number of neutrons than protons remain in a nucleus. That means it is called excessive neutrons. There are some excessive neutrons you can see. So according to this diagram, you can see here there is only one proton. Usually when you come with a hydrogen, there is nothing to repel. Therefore, for a nitrogen, there is no need of having a extra neutron. So neutron, only one proton can remain over here. And there is a second condition, a proton and a neutron both are remain. Here, if you consider the atomic number, both the atomic number is 1. Therefore, this is same element. Here also the atomic number is same. Therefore, the same element, but here the mass number is how much? 1. If the mass number is 2, if the mass number is 3. So you can see that they are all three substances contain same proton or same atomic number. They are for the same element, but the different mass numbers. That is why we call them as isotopes. That's what you need to understand over here, right? This is another example of learning about isotopes. So you can say if you get carbon, usually we have 6 protons and 6 neutrons are there in carbon. There is another version called carbon 13. In carbon 13, there are 6 protons. Therefore, element is carbon, but there are 7 neutrons. The third situation is carbon 14, C14, right? Carbon 14 has 6 protons and 8 neutrons. So this is the mechanism. This is some isotopes of carbon, because we know carbon is a very important point learning about age of dead particles. For example, if you found some kind of a fossil or something, we use this carbon 14 test to count how age it is. Later on, we will learn how does this carbon 14 test functions and what is the mechanism or what is the chemical operation where we have to come up to consider to work out this carbon 14 test. At the later sessions, we learn how does this carbon 14 works, right? The third one, the next example is a very important example, uranium 238 and 235. This is a very popular and very common substance where when we are learning about uh, matter and radiation. So if you consider uranium 235 and uranium 238, uranium 235 contains 92 protons, uranium 238 contains also 92 protons, but there is a different number of neutrons are there. When you consider uranium 235, there should be 143 neutrons, and if you consider the uranium 238, there should be 146 neutrons. So if you consider uranium 238 is more heavier compared to uranium 235, and when you consider the stability, if you get more number of substances in the nucleus, that become more unstable. Out of these two, uranium 238 is heavier, and what happened here is they are kind of unstable when you are considering uranium 235. Uranium 235 is less massive, therefore they are much stable. For example, we know that if you put more number of students in a classroom, what happen? So like if you get more excessive number of students in a classroom, that become much unstable, and you feel so inconvenient to stay in a one classroom with a lot of number of students. So likewise, atom also, this mini substances also same thing, same behavior, where we can see when you become much heavier and heavier in a nucleus, that become more unstable. This is the mechanism where we used to understand about the nuclear radiation. Right. In our next video, we will learn what is this instability and what happens if a atom become unstable.